SN1 reaction, and now we are going to look at the mechanism of SN1. Okay. Please start writing with me. It's like not very complex. I will be explaining as you trying to write it. Mechanism. So in mechanism, please write with me. It occurs in two steps. It occurs in two steps. Number one, breaking of carbon halogen bond or formation of carbocation. So in this reaction, let's suppose we have a carbon atom which is connected to different groups. Let us name it 1, 2, and 3. Okay, so these are some groups. And यहाँ पे एक halogen है आपके पास. There is one halogen here. Now the first here it is quite slow because it is the bond breaking steps. Bond breaking step which is going to require energy. And in this reaction, halogen atom, it takes the electron density away from the carbon atom. This carbon atom, it is now three bonds, and these three bonds are 1, 2, and 3. Okay. After that, I think this will be better. 1, 2, and 3 plus halogen atom, that is the halide ion. Now, in this case, the carbon atom here it is sp3 hybridized, but in this case, by the way, there will be a positive charge. The steric number of carbon atom is only 3. It is sp2 hybridized. It is planar in structure, and this is the carbocation that has been formed. In the next step, please write attack of nucleophile or formation of CNU bond. Let me know if you're done till here. Then उसके बाद I will explain this step this because this is important. Let me know if you're done till here. प्लीज थोड़ा जल्दी लिखिए मरियम एंड ताहा. ध्यान सुनिएगा जरा. ठीक है. डोंट राइट एनीथिंग. हाँ जी सुनिए बिल्कुल. ठीक है. So when the carbon atom is sp2, it will be having three bonds and it will be having one vacant orbital, that is the p orbital. एक यहाँ पे one, here you will be having second group, here you will be having the third group. Or there will be a p orbital which is vacant like this. Now, when the nucleophile it is going to, now this carbon atom is having a positive charge. Now, when the nucleophile is going to attack, when the nucleophile is going to attack the carbon atom, it will put electron density in either this orbital, or rather I should say this lobe. This is one orbital only, p orbital, and which is having two lobes. Either to put on this particular lobe, let me show that with blue pathway, or what can happen, this nucleophile will put on with the red pathway. Or word, I think it is not very good to use. Nucleophile, half of the nucleophile is going to attack on the front lobe, and half of the nucleophiles can attack on the back lobe. Depending, like there will be billions and millions of what carbocation and nucleophile. So by probability itself, we can say that half of the attack could happen through the blue pathway and half of the attack can happen from the red pathway. Does it make sense? Yes or no? Amna, Mariam, and Taha.
Yes, sir.
Right. Now, when the attack happens from the blue pathway, then we will get something like this. Carbon atom, the nucleophile will be added here, and here you will be having the same configuration 1, 2, and 3 as was the reactant. Does it make sense? Yes or no, officially? Because nucleophile is attacking on the front where the halogen was placed. Now, if the attack is happening from the back side, then we will get carbon and the nucleophile will be here, and 1, 3, rather 1, 2, 3 up, and so on. 1, 2, and 3. So in the blue pathway, we can say that the reactants configuration is retained. So we call this retention. Now, in the red pathway, the reactants configuration is inverted. So we call this inversion. 50% inverted product happens, 50% inversion, and 50% 50% retention. And 50% of the product that we get, it is inversion product or inverted product. Inversion product or inverted product. Now, the mixture of these two, because both of these, retention product and the inversion product, both of these will be in the same mixture, in the same solution. That solution is known as racemic mixture. इन दोनों का 50% जो 50% का जो solution होगा ना, in which a solution in which we have 50% product and 50% inversion product, इसको हम लोग क्या कहते हैं? इसको हम लोग कहते हैं racemic mixture. Understood? No, Mariam, Amna, and Taha.
Yes, sir.
मरियम और आमना को समझ में नहीं आया?
Yes, sir.
अब आमना हम आपसे अलग से पूछें? आमना, आमना नहीं होगा क्लास में. चलिए, इसके बाद लिखिएगा SN1 occurs via intermediate carbocation. Therefore, rate of SN1 directly proportional to stability of carbocation. Therefore, the rate of SN1 fastest in 3 degree, 2 degree, और अदर आई शुड से अगर हम सब कुछ इंक्लूड कर देना तो फिर हम लोग क्या बोलेंगे SN1 सबसे फास्ट होगा बेंजाइल में, followed by allyl, followed by 3 degree, followed by 2 degree and followed by 1 degree. ना लिख लिया आप लोगों ने, हाँ या ना? आर यू गाइस डन टिल हियर?
Yes, sir.
Keep on writing. As nucleophile attacks on vacant p orbital of carbon positive, it attacks 50% on one lobe and 50% on another lobe, resulting in 50% inversion and 50% retention. The mixture containing 50% inverted product and 50% retention product is called racemic mixture, and the process is called racemization. Raise your hand if you're done. Waiting for Amna. लिखेगा SN2. This is bimolecular nucleo substitution. In this, rate depends on both substrate and nucleophile, and rate can be given as K into the concentration of haloalkane as well as the nucleophile. So you can say that the order is what? Here the order had 2, and same is the molecularity also. Molecularity is also 2. Mechanism. First of all, it occurs in a single step. थोड़ा ध्यान से देख लीजिएगा यहाँ पे, है ना. So here we have carbon, और वही 1 2 3. यहाँ पे halogen. ठीक है. Now in this step what happens? The nucleophile. अच्छा ध्यान से देखिए जरा. This halogen atom is more electronegative. That is why it will be having what? Delta negative charge. This nucleophile is also having a delta negative charge. So I hope all of you can understand that this nucleophile cannot attack from the front. Does it make sense? Yes or no? Please tell me. Because if the nucleophile is going to attack from the front, it will be repelled by the halogen atom. Halogen atom has delta negative charge as well as has lone pair electron. Correct है हाँ या ना बताइए. Does it make sense? Yes or no? जल्दी बोलो यार, इतना टाइम क्यों लगा रहा है भाई.
Yes,
Nucleophile
sir.
cannot attack from the front because it will be repelled by the halogen atom. Now यहाँ पे you can see that second atom is like this, but it is actually will be below the plane. So I hope you can see there is a cone type of formation. This is front and this is in back. So there is a cone type of formation, and in between what can happen? The nucleophile can come and attack from the back side. यहाँ से ये कैसे घुस सकता है? The second carbon atom, or rather the second group, it is not going to hinder because there is a cone-like structure. Can all of you see that? Yes or no? Please tell me. अरे भाई पता है ना आप लोगों को carbon is going to have a tetrahedral structure in which it is going to have something like this. हाँ या ना? अब ये cone दिख रहा है ना आपको? This is on the plane, behind the plane, in front of the plane. Do you guys know this? अरे यार हाँ या ना? ना बोल दो भाई कम से कम. If you guys don't know Amna, Maryam and Taha, you guys know this structure? Yes or no?
No.
Yes, sir.
Yes or no?
Yes, sir.
Taha, Amna.
No, sir.
ठीक. लेकिन ये चीज ना जल्दी बोला करे. ठीक है.
Yes, sir.
अच्छा आमना, अभी आपकी आवाज आ रही है. See the tetrahedral carbon atom, it is going to look something like this. बॉन्ड कौन चला गया इसका? Can you see the screen now?
Yes, sir.
Just give me a second. अब यहाँ पे जरा कभी कभी पागल हो जाते हैं. कैन यू सी अ कोन लाइक स्ट्रक्चर? ये सुनो, ये जो पीछे नीचे नीचे जो है आपके पास, एक को हमने ऐसे रख दिया ना, ये जो तीन है. बैक हो गया यार. कैन यू सी द कोन लाइक स्ट्रक्चर यहाँ पे?
Yes, sir.
दिस पार्ट है ना, वही हम बस बताना चाह रहे थे. होपफुली आप लोगों को समझ में आ गया हो. हाँ जी, देखो. नाउ what will happen, this nucleophile it is going to attack from the behind, because वही एक यहाँ पे available path है. So nucleophile is going to attack from the behind like this. And as the nucleophile is going to put electron density on the carbon atom, this carbon atom will be breaking the CX bond slowly and slowly. So basically यहाँ पे दो चीज हो रहा होगा. Nucleophile will be forming a bond with carbon atom, one, two, three, and halogen. ठीक है. तो स्क्वायर ब्रैकेट्स वाला. And further, nucleophile, carbon, one, two, three. Okay. So as you can see, this bond it is slowly forming, and this bond is slowly breaking. Okay. And this product that you are going to get, as you can see, backside attack happens. That is why you get inverted product. Now, obviously, you will be getting X negative. यहाँ पे लिखते रहिएगा. SN2 occurs via transition state. Nucleophile attacks from the backside, leading to inversion of configuration and formation of 100% inverted product. बढ़े आगे। आमना मरियम अंताहा।
Yes, sir.
जी सर।
Yes, sir.
जी चलिए, यहाँ तक कोई दिक्कत नहीं है ना? ठीक है, प्लीज ये थोड़ा सा ना थ्योरी वाला पार्ट है, समझने वाला है, याद रखने वाला है, तो इसको ना प्लीज रिवाइज कर लीजिएगा। एज इट इज इससे सवाल आ जाते हैं, ठीक है, इंपॉर्टेंट पार्ट, बहुत इंपॉर्टेंट पार्ट है। ठीक है, इट्स नॉट दैट ऑलवेज रिएक्शन ही आएंगे, इससे भी बहुत बार सवाल आते हैं। नाउ राइट नेक्स्ट, फैक्टर्स अफेक्टिंग SN1 एंड SN2। SN1 एंड SN2 इन जनरल पूरा टॉपिक ही इंपॉर्टेंट है, तो इवन फ्रॉम दिस टॉपिक फैक्टर्स अफेक्टिंग SN1 SN2 यहाँ से भी आपके पास सवाल बहुत आते हैं। ठीक है, राइट फैक्टर्स अफेक्टिंग SN1 and SN2. So we are going to look at few factors. एक वो देखेंगे नेचर ऑफ substrate, then we will look at nature of leaving group, effect of solvent. So these are the three things that we are going to look. सबसे पहले आप लोग डालिएगा हेडिंग नेचर ऑफ सबस्ट्रेट। इसमें reactivity of SN1 and reactivity of SN2. We know that SN1 it depends on the stability of कार्बोकेटाइन, हम लोग ने देखा हुआ है। SN1 जो depends on the stability of कार्बोकेटाइन represented as C positive. Now SN ये किस पे डिपेंड करेगा? It is going to depend on the steric crowding. Alpha carbon, this is the alpha carbon. If this alpha carbon has small groups, nucleophile can easily attack. But if this alpha carbon has large group, it will be difficult for the nucleophile to come and attack. Does it make sense, Amna and Maria? Yes or no? If
Yes,
we are
sir.
if you are having large groups, then it will be physically difficult for nucleophile to go and reach the carbon atom. Amna, make sense यार? Yes or no? जल्दी बताइए, क्या टाइम को लगाते हैं आप लोग? आमना है नीचे क्लास में। चलिए, so SN2 it is inversely proportional to number of groups or are the number of bulky groups on alpha carbon. ठीक है ना. रिएक्टिविटी ऑफ SN1, इसमें ए पार्ट हम देखेंगे, रिएक्टिविटी ऑफ SN1. A few points that you need to, carbocation is stabilized by electron dating groups, and carbocation is destabilized by electron withdrawing group. So we can say that if I talk about the stability of carbocation, then it will be directly proportional to the plus M group, inversely proportional to the minus M group, and it will be directly proportional to the plus I group and inversely proportional to the minus I group. That means plus M and the plus I groups are going to stabilize the carbocation by giving them electron density, and the negative minus M and minus I are going to reduce the electron density, making it more and more unstable. अगर हम in general rate of SN1 की बात करें, rate of SN1, we have already seen this of SN1, then it is benzyl, उसके बाद allyl, उसके बाद 3 degree, then you have 2 and then you have 1 degree. ठीक है, तो benzyl का स्ट्रक्चर कैसा होगा? benzyl will be something like this is the benzyl carbon. Allyl, this is the allyl carbon. 3 degree will be something like this. Halogen atom. This is the 3 degree carbon. 2 degree and 1 degree will be something like this. This is 1 degree carbon atom. ठीक है, so this is fastest followed by this. By the way, allyl में ना almost same ही रहता, ठीक है, तो I am equal to, लेकिन ये comparison आपको कभी नहीं देगा because it depends on what type of allyl we have and what type of 3 degree carbon we have. अब लेकिन आपको सवाल कैसे करना वो हम आपको बता दे रहे हैं. If you have not written, don't worry, I will give you time. ठीक है, ध्यान दीजिए जरा. रेट ऑफ SN1, रेट ऑफ SN1, दिस इज वेरी इंपॉर्टेंट. इसी से सवाल बनेंगे. रेट ऑफ SN1, first of all you need to count the number of benzene ring on carbon atom, directly proportional to number of benzene ring, या फिर इसको कैसे दिखा रहेगा? C6H5 on alpha carbon. If the number of benzene ring is more in someone, you don't need to look anywhere else, सीधा आप लगा दीजिएगा उसी को. If the number of benzene ring is same, or if the benzene ring is not available, then number of alkyl group, that is R group. R मतलब CH3, C2H5, anything on alpha carbon. जल्दी से कॉपी कीजिए, then we will do some question. Let me know once you're done. Please raise your hand once you're done. चलो. Write a question. Predict the order of reactivity of following in SN1. C6H5CH2 Br, C6H5 carbon, then CH3, then C6H5, and then Br. Then you have C6H5, CH, C6H5, Br. Then you have C6H5, CH, CH3, CH3, Br. A, hopefully you can see the comma, है ना? This is B, C, and D. आर यू गाइस डन राइटिंग? जल्दी लिख लीजिए जरा सवाल को, उसके बाद आगे बढ़ते हैं। जल्दी हो गया? आमना मरियम ता
Yes, sir.
ठीक है। आप सबसे पहले काउंट कीजिएगा नंबर ऑफ C6H5 इन ऑल ऑफ दीस। ठीक है, सिंपल तरीका मैं पहले आपको बता देते, देन आई विल एक्सप्लेन इट आल्सो। ठीक है, सिंपल तरीका। हाउ मेनी C6H5 इन दिस केस? द फर्स्ट वन, ए में कितने C6H5 है जल्दी बताइए। हाउ मेनी C6H5 द बेंजीन रिंग इन द फर्स्ट वन, जल्दी बताओ। मरियम दाहा कीप योर माइक ऑन। मरियम दाहा कीप योर माइक ऑन। हाउ मेनी C6H5 इन द ए केस?
Sir, one.
वन। इन द सेकंड, बी में कितने C6H5 है? मरियम समझ में आ रहा है? मरियम,
Yes, sir.
इन द बी हाउ मेनी C6H5?
Sir, two.
टू। हाउ मेनी C6H5 इन द सी केस? मरियम तो बोल क्यों नहीं रहे? आपको समझ में आ रहा
Two.
था? मरियम बताइए।
2, sir.
टू। और थर्ड डी वाले में?
One.
वन। ठीक है, चलिए। अब दिस इज फॉर C6H5, है ना। अब उसके बाद देखना आपको एल्काइल ग्रुप। फाइन। तो फर्स्ट वाले में तो जीरो एल्काइल ग्रुप, ओनली वी हैव C6H5 एंड देन वी हैव हाइड्रोजन। ये सुनो प्लीज चलनी।
Yes.
नाउ इन द बी केस वी हैव C6, दो C6H5 और एक ये एल्काइल ग्रुप दिख रहा है CH3, हाँ या ना?
Yes.
Here also we have two C6H5 and then we have hydrogen which is not an alkyl group, so zero. Makes sense, yes or no? Please tell me.
Yes.
Here we have one and then one CH3, so we have one CH3. Make sense?
Yes.
Now, सबसे पहले what do we look at C6H5 या फिर alkyl group? क्या देखते हैं पहले?
C6H5.
हाँ, so according to C6H5, which will be the fastest out of the four? Which will be the fastest? Which two will be the fastest?
Um, B and D.
B and C ना, because B and C
B
में
and C,
आपके
yes,
पास
sir.
दो
B
थे।
and C.
B and C, हाँ ठीक है। Okay. Now, in B, since C6H5 is same, we look at the alkyl group. So according to the alkyl group, which is going to be the fastest, दोनों को consider अगर हम कर ले तो B और C, which will be faster?
B.
B will be faster ना। तो सबसे पहले B and obviously उसके बाद तो C हो जाएगा, because B और C में ही देख रहे थे। Now, between A and D, which will be faster?
D.
D and then A। आ गया?
Yes.
Copy this down. मरियम आपको आया?
जी, sir.
अच्छा। Done writing, yes or no? Please tell me.
Yes, sir.
Yes, sir.
सेकंड लिखिएगा। दिस इज द रिएक्टिविटी ऑफ SN1। यही थोड़ा डिटेल है, तो मैं तो बस आपको थोड़ी चीज याद करनी पड़ेगी। सेकंड, reactivity of SN2। सिंपल रेट में यहाँ पे CH3X will be fastest, followed by this will be fastest, followed by 1 degree, followed by 2 degree, and the slowest will be 3 degree. Because here we have 0 bulky group, यहाँ पे 1 bulky group, यहाँ पे 2 bulky group, यहाँ पे 3 bulky group, and that is why 3 degree is not going to show SN2. And there are few points इसको जरा लिख लीजिए, note important है ना. Alpha unsaturation, alpha unsaturation always decreases the reactivity of SN1 and SN2 both. दोनों की reactivity का कम हो जाएगी. What is the meaning of alpha unsaturation? Meaning if the alpha carbon it is having a double bond, if it is unsaturated, for example, vinyl halide. This is the alpha carbon and it is having unsaturation. ना ये क्या है? Vinyl halide. Vinyl halide. If I compare the reactivity of nucleophilic substitution, whether it is SN1 or SN2, in comparison to simple haloalkane, then this will be faster. Similarly, आपके पास आ सकता है something in cyclic also, alpha unsaturation. But if you take a simple cyclopentane, then the simple cyclopentane will be faster. Similarly, if I take a aryl halide, and if I take a cyclohexane halide, cyclohexane will be faster. Now, why does this happen? It happens because of resonance. Because when in vinyl halide type of cases, this lone pair comes here, and then this negative charge goes there, and making this bond partially double bond. If this is partially double bond, it will be difficult to separate. ठीक है ना? It will be difficult to break. और दूसरी डिटेल लिखाएंगे, SN1 SN2 सब कुछ लिखाएंगे. Like why the reactivity decreases for SN1 and why the reactivity decreases for SN2. दोनों चीज लिखाएंगे. So write this down, raise your hand once you're done. Mariam done?
Yes, sir.
वही इसको एक्सप्लेन करते हैं, है ना? प्लीज राइट इन SN1 the carbocation, rather the CX bond is difficult to break as it has partial double bond character. It has partial double bond character. ठीक है, that is why it will be difficult to break. अब उसके बाद difficult to break तो है ही, Now, if here we are going to break the CX bond, then what's going to happen? Okay, it has partial double bond character. Now, if we the carbocation also, say if the bond breaks and carbocation forms, then it will be unstable due to the presence of highly electronegative, highly electronegative sp2 carbon, sp2 carbon. Okay. So first of all, the CX bond will be difficult to break. और दूसरी चीज, even if we break it, then we will get something like this: CH2 double bond CH positive. Now this CH2 will be what? It will be highly electronegative because of sp2 hybridization. It will pull the electron density, and if it is going to pull the electron density, then it's going to be very unstable. That is why it does not form. The carbocation is not formed. पहली बात तो फॉर्म ही नहीं होगा because of partial double bond character. अगर हीट वगैरह देके फॉर्म कर भी लिया हम लोगों ने, then also it will be unstable. तो SN1 से तो हो नहीं सकता है. What happens in SN2? SN2, the nucleophile is repelled by electron-rich pi bond, and therefore it does not attack. Okay, so you know that in double bond, and here we have halogen, so the nucleophile will come and it is going to attack on this, like this. Nucleophile is going to attack like this. Now, if the nucleophile is going to come from the back side, you can see that there is an allyl carbon which is having a partial double bond and a pi bonds. These pi bond is going to repel the nucleophile. It will be difficult for the nucleophile to come and attack it because of the repulsion. Does it make sense? Yes or no? Please tell me. Pass it.
Yes, sir.
Please copy this down. Raise your hand once you are done. You can also make a resonating structure like this. Let me know once you're done writing. Please raise your hand once you're done. Taha, just waiting for you. चलिए. Right, next, nature of living group. Leaving group, I hope you guys remember that the halide ion is going to be leaving group. So leaving group, whenever it leaves with a negative charge, right? यहाँ पे देखिए, ना, halide ion is going to leave with a negative charge. So the halide ion should be something which has the ability to bear the negative charge. If it can bear the negative charge easily, it will leave easily, है ना? So please write यहाँ पे. The leaving group should be able to bear the negative charge. Hence, larger the size of leaving group, faster is the reaction. So rate directly proportional to size of leaving group. Therefore, if I compare the rate, then between alkyl chloride, alkyl chloride, alkyl bromide, and alkyl iodide, then alkyl iodide will be fastest, followed by bromide, and then followed by chloride and chloride. Just waiting for Mariam Lohani. Done. Next लिखिएगा nature of solvent. यहाँ पे लिखिएगा polar protic solvents increase the rate of SN1 and hinders the reactivity of SN2. नेक्स्ट पर लिखिएगा polar aprotic solvent are used in इसको लिखिए, then I will explain like what is polar protic and what is polar aprotic, what is solvent and all of those things. Just let me know, Taha and Mariam, once you're done. Done, Taha and Mariam?
Yes, sir.
Yes, sir.
या ठीक है, ध्यान सुनिएगा, ठीक है ना, ये लिखना नहीं है, ध्यान से बस सुनिएगा, माइक ऑन करके बताते जाइएगा, फाइन। ठीक है, सबसे पहले कटायन की बात, व्हाट इज पोलर? पोलर का मतलब जिसमें क्या हो, पॉजिटिव और नेगेटिव। अरे हाँ यार, माइक ऑन करो भाई, मरियम एंड साहब, प्लीज योर माइक ऑन। अच्छे से समझिएगा, पोलर, यू मीन व्हाट इज पोलर? पोलर का मतलब होता है विच हैज डाइपोल मोमेंट, पॉजिटिव एंड नेगेटिव। दैट मीन द सॉल्वेंट शुड बी, it should be having certain dipole moment. For example, pani, water is going to have a dipole moment because oxygen is delta negative, hydrogen is delta positive, and delta positive. There will be a dipole moment, something like this. Make sense? This one, please tell me. समझ में आ रही
Yes,
है? और उसी के
Yes,
हिसाब
sir.
से एक apolar solvent होते हैं. There are some apolar solvents. For example, carbon tetrachloride, Cl, 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 and Cl. You have seen in the dipole moment. Dipole moment cancels in this case in CCl4, and it is what, non-polar. आया ना बताइए, mu net it is equal to 0. So there are certain solvents which are polar and there are certain solvents which are apolar, non-polar. Make sense? Yes or no? Please tell me.
yes,
अरे बोलो भाई।
Yes, sir.
ठीक है, अब similarly in, you have to just look at the polar solvents. Why we are going to use the polar solvent? Because haloalkane is polar, delta negative and delta positive. So haloalkane is more miscible. And also one more thing, when we are going to have a nucleophile, then this nucleophile is going to have a negative charge or a very high electron density. Then obviously the nucleophile will be having some polar component. And this nucleophile will only be soluble in polar solvent. Like dissolves like. Does it make sense, Mariam and Taha?
yes, sir.
Yes, sir.
ठीक है, चलिए, that is why we are going to use always polar solvent. अब polar में there are two things, polar protic and polar aprotic. So what is the meaning of protic? Protic means which can give H plus. I am not saying which it can give H plus. I am not saying it gives H plus. Rather, it can give H. इस आइडिया को आप लेके चलिएगा. But in fact, the exact meaning of polar protic is solvent which forms hydrogen bond. For example, water. For example, ethanol. Example, methanol. ठीक है, all of these are the examples of what, polar protic solvent which can form hydrogen bond. So what the polar solvent do to make the reactivity of SN1 faster, and how do they increase the reactivity of SN1? इसको हम लोग समझते हैं, ठीक है, ध्यान सुनिएगा जरा. In SN1 in SN1 the rate depends on the stability of what, Mariam and Taha? In SN1 the rate depends on the stability of what, Mariam and Taha? अरे रे रे, Mariam and Taha, the rate
Yes,
of
sir.
SN1, it depends on the stability of, अरे ये नहीं पता क्या मरियम एंड ताहा, आज को इतना पढ़ाया? रेट ऑफ SN1
The
it depends on what? बोलो बोलो ताहा बोलो.
the stability,
Stability of what? हाँ, stability of
carbocation.
what? ठीक है, तो कार्बोकेटायन will be having a positive charge. Let's suppose we are using a polar protic solvent. What we are using? Polar pro. What are we using, Mariam and Taha? Polar
Water,
protic.
oxygen.
हाँ, polar protic. For example, water. So as soon as we use polar protic solvent, the water molecule will surround the carbocation like this. Does it make sense? Yes or no? Please tell me.
Yes, sir.
Does it make sense, Mariam? Yes or no? Please tell me.
Sir, can you repeat एक बार?
Sure. This is the carbocation. Just showing it by positive charge. Does it make sense, Mariam?
Yes, sir.
And we are using a polar protic solvent. What solvent?
Polar project.
Just give me a second. See. Now, if you are using polar protic solvent, then, for example, water. So, water, it has delta negative charge on the oxygen atom. So, this oxygen atom is going to be attracted by the positive charge like this. क्या ख्याल है? Does it make sense?
Yes, sir.
So there is attractions when we add polar protic solvent in SN1. So these attractions, they stabilize carbocation. Make sense?
Yes, sir.
अब what is going to happen if I use polar protic solvent in SN2? ध्यान से let us suppose we are using a simple haloalkane like this and we want to attack the ammonia here. But if we are using water as a solvent in this case, then the water molecule also has lone pair electron and this can also attack here. Does it make sense? Yes or no, please tell me.
Yes, sir.
Yes, sir.
That is why we cannot use polar protic solvent in the case of SN2. Make sense? Yes or no, please tell me.
Yes, sir.
Okay. So I can write like this. Polar protic solvent increases rate of SN1 by stabilizing carbocation. And polar protic solvent decreases rate of SN2 by attacking the substrate Got this? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
लिख लिया आप लोगों ने?